Hey everyone, and welcome to today's Explainer. We're going to be diving into a genuinely fascinating proof of concept today, and it literally challenges everything we've just come to accept about modern AI agents. You know the trend, right? If you've been watching the AI space even a little bit, you see it. Models are getting absolutely massive, data centers are just devouring power, and the architectures, they're incredibly complex. The whole industry is basically sprinting toward these gigantic, always-on cloud brains. But today, we're putting on the brakes. We're looking at a project from developer Stefan Manninen that goes in the exact opposite direction. What if the next huge leap in personal AI isn't about getting bigger at all, but about getting microscopic and deeply, deeply personal?
So, let's start with a really provocative what if. Imagine a personal assistant that actively tries to reduce its reliance on heavy compute the more it learns about your habits. Think about it like writing a bash script. You write a script to automate a task, right? You do that so you don't have to manually type out some long, complicated command every single day. Well, Mannin's micro assistant operates on that exact same principle. Instead of spinning up massive language models for every single repetitive little task you ask it to do, it literally trains itself to be, well, lazy. But lazy in the absolute best, most efficient way possible. It actually wants to do less work today than it did yesterday.
All right, so here's our roadmap for this explainer. First, we'll look at the cloud AI problem. Second, enter the micro assistant. Third, we'll break down the four-part architecture. Fourth, the execution flow matrix. And finally, we'll wrap up with limits and future vision.
Okay, jumping right into part one, the cloud AI problem.
Before we can really appreciate how elegant this local solution is, we have to talk about the massive frustration developers and power users are feeling right now with standard AI architectures. Today's bloated cloud AI basically demands a content internet connection, it costs an absolute fortune in API calls when you scale it up, and honestly, the worst part? These models are total black boxes. They have these completely opaque, hidden behaviors. You really don't know how they're routing your data. But in stark contrast, this micro-assistant approach runs entirely locally on your own machine. It's totally transparent, it has a tiny footprint, and it's highly resource-aware. It's basically taking the power dynamic and handing it right back to the user's terminal.
Which brings us to part two. Enter the micro-assistant.
Let's look at the core premise of this adaptive local terminal assistant and what it's actually trying to do on your machine. The whole idea is simple, but it's pretty radical. API calls, web searches, and model invocations should decrease over time. The key here is that the system uses a SQLite-based reinforcement policy. Basically, it learns when to reuse a good answer, skipping the unnecessary LLM call entirely. So if you ask your assistant to run a specific network diagnostic today and it figures out the right bash command, it saves that route. Tomorrow, when you ask for the exact same thing, it doesn't need to go ask an AI model how to do it all over again. It just remembers. And the performance benefit of this memory is just wild. 0.83 milliseconds. When the system gets a full local intuition hit, it pulls verified answers from SQLite in just 0.83 milliseconds. To put that in perspective, a standard API call to a cloud model might take 2 to 3 whole seconds just for the round-trip latency. By bypassing the language model completely for tasks it already knows, this local assistant is practically instantaneous. It doesn't even feel like you're talking to a chatbot anymore. It feels way more like triggering a super optimized keyboard shortcut.
So how does it pull this off? Let's get into part three, the four-part architecture.
Let's open up the hood here and look at the multi-layered tech stack making this hyper-efficiency possible, right on your local hardware. The system is incredibly clever. It combines two very small sub-1 billion parameter local models with a SQLite database and this really critical validation layer. So first, it uses a tiny model called Gemma 3270M, and that's just to understand your voice and figure out your basic intent. Then it passes that intent to function Gemma, which acts as a tool router to generate structured JSON actions. Step 3 is the SQLite policy layer. This is the local intuition we talked about, where it stores all your repeated patterns. And finally, the fourth piece is the cleaner or critic layer.
You can really think of this cleaner layer as a biological immune system. It's explicitly designed to filter out weak or bad training candidates. Because think about it. If an AI hallucinates a completely wrong terminal command, the absolute last thing you want is for the system to permanently memorize that mistake and then instantly repeat it back to you tomorrow. This critic layer detects those bad cached answers and noisy memories. It essentially fights off the bad data before it can infect the assistant's permanent intuition.
Let's move on to part 4, the execution flow matrix.
Okay, let's see this in action.
How does the assistant actually evaluate your input before deciding to wake up those model weights? It's basically a traffic light system. If it registers a full hit, meaning both the route and the answer have high confidence scores, green light. It skips a llama and the AI models entirely to give you that sub-millisecond response straight from SQLite. Now, if it's just a yellow routing hit, it means it knows which tool to use, but it doesn't have the exact answer saved yet. So it skips the initial intent analysis and goes straight to the tool router, which still saves you precious compute time. And finally, if it's a red cache miss, meaning it really has no idea, then and only then does it run the standard heavier AI pipeline.
All right, wrapping things up with part 5, limits and future vision.
Now, to be completely fair, this is an early stage proof of concept, so we definitely need to ground our explainer by acknowledging its current boundaries, while also looking at the super exciting direction it's heading. Right now, the biggest limit is that it relies heavily on exact hash matching, not semantic similarity. What that means is, if you ask a question using even slightly different phrasing, the cache is probably going to miss it, because it's looking for an exact word-for-word match. On top of that, the answer validation is still a bit weak, tool execution is pretty early stage, and rewarding the system for good behavior is currently a manual process. But honestly, these limitations are just paving the way for a really ambitious roadmap. The ultimate goal here is to build a real fine-tuning pipeline, kind of like LoRa, where these cached memories actually retrain your local model over time.
The creator makes a fantastic point here. Unlike standard RAG systems, retrieval augmented generation, where a system just goes and fetches data, a true personal assistant should dynamically adapt to your specific workflows. Memory should not only be retrieved, useful behavior should eventually be learned. Most systems today just read a PDF and summarize it, but this micro-assistant concept aims so much higher. It wants to learn how you work, actually taking that external tool usage and promoting it into local intuition. It's effectively tailoring itself to your exact digital fingerprint.
And this whole project reflects a deeply transparent, anti-black box philosophy. AI should assist understanding, not replace it. In a world right now where big companies are pushing these autonomous agent swarms that just run wild in the background doing who knows what, this project insists on the opposite. Every learned shortcut is stored locally, it's explicitly weighted, and most importantly, it can be inspected or cleaned out by you, the user. You are always in control.
So I'm going to leave you with this final provocative thought as we wrap up our explainer today. Is the future of personal AI bloated in the cloud, or is it learned locally, right there on your own machine? Stefan Mannen's micro-assistant proves that by trusting small, sub-1 billion parameter models and using clever local caching, we can achieve absolutely blistering speeds while maintaining 100% privacy. It completely challenges the "bigger is always better" narrative. It asks us to imagine a future where our AI tools are small, lightning fast, and uniquely our own. Thanks so much for joining me to unpack this fascinating architecture, and keep exploring the systems that power your daily workflows.